Welcome to section 6.6, % yield. The learning objective for this section: know the meaning of actual yield, theoretical yield, and % yield. Calculate the % yield of a chemical reaction. So I want to talk about these three definitions, and then we'll look at an example. Everything we've been doing so far with stoichiometry has essentially been finding a theoretical yield. Every time you're given some amount of a reactant and asked to find how much of a product you would create, you are determining a theoretical yield. The theoretical yield is an amount of the product that you would predict from an amount of one of the reactants. The actual yield is what happens in the lab when you perform an experiment. The actual yield, as you probably at this point know from having done some experiments, is not always perfect. It is possible for lots of things to go wrong in the lab, some of them beyond your control, some of them perhaps things you could have done to avoid. In any case, it is probably not realistic to expect the actual yield to perfectly match the theoretical yield every single time. So we want to have a way of comparing them in a useful way. And that way is the % yield. The % yield is defined as the actual yield divided by the theoretical yield times 100%. So what you do is you take the amount you found in the lab, probably with units of grams, and divide it by the amount you would predict to find, again, in units of grams. It is essential that when you use the % yield equation, that the units here are identical to the units here. Not just that they're both grams, but that they're both grams of the same thing. You absolutely have to do this theoretical yield calculation before you can use the % yield equation. So everything needs to be in units of your product, probably grams of your product. Let's look at an example. Feel free to go ahead and pause your recording, try to solve this, and come back and see if we get to see what the correct answer is. Okay, so our question: what is the % yield if 40 grams of carbon monoxide is produced when 30 grams of oxygen is used? Let's go ahead and start keeping track of some potentially useful information. So we are looking at carbon monoxide, so maybe we want to know the molar mass of carbon monoxide. So we would say 1 mole of carbon monoxide is equal to 28.01 grams. So we get that by adding the carbon and the nitrogen. Actually, and I did it incorrectly, right? That should be 26.01 grams. So we have 14.01 plus 12.01, actually 26.02, right? 26.02 grams. We have carbon monoxide and we have oxygen, so we care about that relationship. So we could say that 1 mole of O2 is equal to 2 moles of CO from the balanced equation. And then we have grams of oxygen. We can say 1 mole of O2 is equal to 32.00 grams from the periodic table. We have our three conversion factor, three equalities to base our conversion factors on. And then we have these other numbers given in the question. And sometimes the tricky part here is knowing where to start. Do we start with the CO or do we start with the O2? For a % yield question, we know it's that because it's saying percent yield right here, we want to start with the reactant. So O2 is our reactant. We can say reactant is 30 grams of O2. Product is 40 grams of CO. So we're going to start with the reactant. We're going to come back to the product when it's time to find percent yield. So we start there, 30 grams of O2. We want to first find moles. So we have the molar mass, 1 mole of O2 on the top, 32 grams on the bottom. We do our conversions. We're looking for CO. So we use that one. We're using this one next. So 2 moles of CO on the top, 1 mole of O2 on the bottom. And then finally, we use our molar mass for the product, 26.02 grams on the top, 1 mole of CO on the bottom. When I do the math here, I get 48.8 grams of CO. What we have just found is the theoretical yield of our product of carbon monoxide. To find the percent yield, we take actual divided by theoretical times 100%. So the actual yield is given in the question. And we wrote that down here. Our product is 40 grams of CO. We might have actually even called this the actual yield. So 40 grams of CO on the top. Our theoretical is what we just found, 48.8 grams of CO. Very important that as you're doing this step, the units match. Again, grams of product have to be the same thing. There might be a few cases when you are given 2 numbers and one of them is theoretical, one is actual. In that case, you can just go ahead and do this calculation. Most of the time, you will have to do the theoretical yield, find the theoretical yield first before finding it with percent yield. So when you do the math here, you should get something like 82.0% as the percent yield for this problem. Okay, so that is the end of section 6.6. Go ahead and complete the worksheets for this section. Ask questions on the discussion board related to this material, and then proceed to 6.7 when